Every single time you check the weather, or you pull up a map on your phone, or even watch a live game from halfway around the world, you're actually using this incredible network of machines that are just hurtling through space. We're talking about satellites, our eyes in the sky. Seriously, they're so woven into our daily lives that we don't even think about them. They're this silent, invisible infrastructure that's just powering our modern connected world. From your bank transactions to your TV shows, they are the unsung heroes up there. And that brings up a really good question, right? I mean, these things are zipping along at thousands of kilometers an hour in a complete vacuum. There's nothing holding them up. So what's the secret? What keeps them from just crashing back down to Earth? Well, here's the secret, and it's going to sound a little weird. They aren't floating at all. They're actually falling. Yeah, it sounds like a total contradiction. But the whole idea of keeping a satellite up there is based on this beautiful piece of physics about falling. So let's break it down. What even is a satellite? Well, in the simplest terms, it's just anything that orbits a planet. I mean, our moon is a natural satellite, right? But the ones we build, they are these amazing feats of engineering, all based on this principle of falling with style. Okay, picture this. Imagine you're on a super tall mountain and you throw a ball. Gravity pulls it down, it lands. No surprise there. But now, what if you could throw that ball so incredibly fast that as gravity pulls it down, the round Earth curves away underneath it at the exact same rate? It would just keep falling and never actually hit the ground. That, my friends, is what an orbit is. So what's inside one of these things? What makes them tick? It helps to think of a satellite almost like a living thing. It has its own set of internal organs, and each one has a super critical job to keep it alive and working in the really harsh environment of space. Now, even though every satellite is different, they all share three absolutely essential systems. You've got to have power, you've got to be able to talk, and you've got to be able to steer. So let's take a look at each one. First up, the power system. This is basically the satellite's heart and lungs. You know those big, shiny wings you always see on them? Those are actually huge solar panels, just soaking up sunlight and turning it into electricity. But what happens when the satellite goes behind the Earth and into its shadow? Well, that's what the onboard batteries are for. They kick in and keep everything running smoothly. Okay, so it has power. Now it has to do its job, which is to talk to us. The communication system is basically its mouths and ears. It's a bunch of antennas that are constantly beaming down all sorts of data and listening for new commands from us down here on Earth, all using radio waves. Now for the really clever part. How do you steer something when there's no air to push against? You can't use wings or rudder in space. This is where some brilliant physics comes in. Satellites use things called reaction wheels, basically internal flywheels that spin up to turn the spacecraft. Or they use tiny thrusters that puff out little jets of gas to nudge themselves into the perfect position. So cool. All right, so not all satellites live at the same address. Just like a city has different neighborhoods, space has them too. And where you decide to put a satellite depends completely on what job you want it to do. Location, as they say, is everything. The two main neighborhoods are LEO and GEO. LEO, or low Earth orbit, is kind of like the busy downtown street right above our atmosphere. It's crowded with things like the International Space Station and a ton of observation satellites. Then you go way, way out, and you get to GEO, or geostationary orbit. That's the fixed spot that's just perfect for things like TV broadcast and weather satellites. And when I say LEO is busy, I also mean it's fast. Satellites in low Earth orbit are absolutely screaming through space. Get this, they can do one full lap around the entire planet in just 90 minutes. Can you imagine that? Seeing a sunrise and a sunset every hour and a half? Now, compare that to GEO. At the very specific altitude of 36,000 kilometers, something magic happens. A satellite's speed perfectly matches the rotation of the Earth below. So from our point of view on the ground, it looks like it's just hovering there in one fixed spot. That's exactly why your satellite TV dish never has to move. And of course, there are other specialists out there in different orbits. The whole GPS network that helps you navigate flies in what's called medium Earth orbit, or MEO, somewhere in between. And then you have Earth observation satellites in these really special orbits that let them scan the entire surface of the planet, tracking everything from forest fires to melting ice caps. So we know what a satellite is and we know where it lives. But how in the world does a machine the size of a bus get there in the first place? Well, you essentially strap it to a very big, very powerful, and very precisely controlled bomb, also known as a rocket. Here's maybe the biggest misconception about getting into space. The hard part isn't just going up. That's actually the easier part. The really, really hard part is getting enough sideways speed, we're talking 28,000 kilometers an hour, to get into that falling with style orbit we were just talking about. So a rocket launches straight up, just to punch through the thickest part of the atmosphere as quickly as possible. But then it starts to do what's called a gravity turn, tipping over sideways to build up all that horizontal speed. To save fuel, it drops its empty tanks in stages. And then finally, once it's up in the vacuum of space, the nose cone, that's the fairing, splits open and gently pushes its precious cargo out into its new home. So all of this incredible technology has led us to right now, a time where the sky above our heads is anything but empty. We've basically turned the space right above Earth into this bustling, invisible highway of information. As of today, there are thousands of active satellites orbiting our planet, everything from tiny little cube-shaped ones to massive telescopes. They all form this invisible web that our whole global civilization really depends on. And yeah, it is getting pretty crowded up there. And believe it or not, we're really just getting started. We're now entering what's being called the era of mega-constellations. These are huge networks of hundreds, sometimes even thousands of smaller satellites all working together. And their goal? To blanket the entire globe in high-speed internet. We've turned what was once a black, empty void into a real hive of human activity. So the next time you're outside on a clear night and you see a steady little point of light silently gliding across the stars, you'll know that's not a star and it's not a plane. It's one of ours. It's a satellite, falling with style and working hard for all of us down here. Give it a little wave.